Hola, students. Welcome to your video lesson on finding volumes of prisms and cylinders. So you're going to look at rectangular prisms, triangular prisms, and cylinders. Volume is a new vocabulary word, and you are going to want to have space to work down and show your notes and remember to label. First, we need to know what volume is. Volume is the measure of space occupied by a three-dimensional figure. So when you figure out how much soda can go in your bottle, that is you figuring out the volume that that bottle holds. So the volume is in cubic units because you are multiplying units times units times units. So this is an example of a rectangular prism. Its base is a rectangle. And so the bottom layer, how volume works, is when you fill something, it doesn't fill up vertically first, it fills the bottom first. Gravity, And so you fill the bottom layer, and so this shows an example of a base of 6 by 6, so you're filling up an area of 36 cubes, but then you're filling up 2 units. So you have that 36 2 times. So that looks like 6 times 2. The formula for this, for volume, is going to be volume equals capital B, which stands for the base area, and then H, which is the height from base to base. So if you look at this image, this 6 by 6 square, technically, is your base because it's parallel to this top one, and the difference between them is that height. So in a rectangle, we still call this length times width. The other formula that you'll use for rectangular prism is length times width times height, because again, that B stands for base area, and that will change depending on what the shape of your base is. So the base area formula for a rectangle is length times width, hence why that is replaced right there. So let's do a couple examples, and then we will move on to some real-world examples of why we need to know the volume. So we are first, and again, showing your work is imperative in these because it helps you, not because we're being picky. So volume, I'm going to write out the formula. Volume is base area times the height. Well, my base shape is a rectangle, so volume is length times width, which is the area, then times the height of that figure. So notice I wrote the formula, rewrote the formula, replacing base area with the formula, and then I'm going to plug in the values. So my length here is 5, my width is 4, and my height is 3. So then I work down. So notice formula, plug in, work down. 4 times 5 is 20, then that times 3. So my volume is 60. Notice here I did units times units times units. So this volume is in centimeters cubed. Try another one if you're ready. Go for it. So again, finding the volume. So I wrote my volume is base area times the height. Since it's a rectangular prism, my base area formula is length times width. Multiply all that by the height. Notice I'm showing various ways to multiply. Parentheses and dots, and variables next to each other. Plug in the values I'm given. My length of 9.5 times my width of 5 times my height of 3. I like to multiply, since multiplication can go in any order. I like to do the ones I'm familiar with first. I like to use a calculator not until the very last bit that I have to, because I think we make more mistakes that way. So 5 times 3 is 15. Then I do 9.5 times 15, which is 142.5 cubic meters. Ta-da! Okay, so let's use volume in a career sense. Maybe you are a marketing researcher and you are trying to figure out which lunchbox to manufacture. So we figure out which one holds more food. That's figuring out which one has more volume. So you have to make a comparison from one lunchbox to another. So you figure out the volume of both. So for lunchbox A, finding the volume, base area times the height, It's a rectangular prism. And again, you could pick length and width. Since it's multiplication, they go in any order. So some of you might said that 7.5 was the length. Either way, length times width times height. So then I plug in my length, my width, and my height. And I work down. So notice this is same formula, plug in, work down. When I do that multiplication here, I get 125 thousandths times 10. So my volume is 281 and 25 hundredths cubic inches. So then I find B, and I label my parts. So I'm going to use volume as base area times the height. So a rectangular prism, so area is length times width. And I plug those values in. Notice we can't just assume which one because the values are different, but they change by the same amount. So that might be tricky for us to figure out. So we actually do the math and find out here. So my volume then, I get this multiplied together, I get 30 times 9.5. So I find out the volume is 285 cubic inches. So what I can say is that container B holds more, has a greater capacity for volume, a greater capacity for food. Okay, so justifying your answer. I'm going to move on to the other shapes. You can try this one, and then we can talk about it in class if you'd like. Now we have triangular prisms, okay? So this is our second to last shape. Triangular prisms are prisms that have a triangular base, whereas rectangular prisms had a rectangle for the shape of the base. Important not to confuse height of the triangle with the height of the prism, okay? So be careful with that. The base of a triangle, so we use the base area formula, 1/2 base times height. Notice our base triangle is here and here. So the height of the prism, remember, is the distance from base to base. Here's your formula again. We have volume still is base area times the height. But in this case, for a triangle, our base area is 1/2 base times height. So you're going to generally see me do this. I'm going to make that H capitalized just so I can kind of keep knowing the difference, like they said, that study tip, between the height of the triangle and the height of the prism. Those are two different heights. So let's try some of these. First thing is important to identify your parts. So I know that I'm going to be finding volume. So I'm going to use my volume formula, equals base area times the height. And I know that my base is a triangle. So I'll be using 1/2 the base times the height as the base area formula. So I have my base of the triangle of 8 and the height of 6. From base to base, we have a height of 9. So even if we flip that over on its side, it's important to recognize which is your base shape and what's the distance between those. So we plug in those values. 1/2 base of that shape was 8. Height of it was 6. Height from base to base was 9. So then I get 4 times 6 times 9, which is 24 times 9, which means that we have a volume. Did I make a mistake in there? 4 times 6. Nope. So 24 times 9. And I'm going to get, well, 24 times 10 would be 240. So I'm going to do 240 minus 24 for 216 cubic feet. So notice how I didn't, I worked all the way down until I got my answer. Here are two for you to try when you're ready, or try them, come back and check. So label, we're looking for volume, base area times height. with a base of a triangle, which means I'll be using 1/2 base times height times the height of the prism. So we'll label our pieces. Base of 4, height of 5, height from base to base is 7. So I have 1/2 times 4 times 5 times 7, which would be 2 times 5 times 7, which is 10 times 7, for a volume of 70 cubic inches. Bear with my writing, please. Really, really, really encourage you to try this one on your own and then come back. So you would have had your base of 3, height of 6, height from base to base of 5.2. So I'm going to kind of whip through this one, writing my formula per usual, replacing that formula with the base area formula I'd like to use, replacing those values with the values from the given shape, and then working through it. So I get 1/2 of 6 is 3, 3 times 3 is 9, so I have 9 times 5 and 2/10, so the volume here is 46 8/10 cubic millimeters. Ta-da! Last one, we're doing this cylinder, and we only have a couple problems trying with this. A cylinder now is a 3-dimensional figure that has a base that is a circle. So to find the volume of this, and this is what soup is often in, to find the volume of this, you find the base area, which the area of a circle is pi r squared. So instead of using this, we can use this here. Volume is base area, pi r squared, times the height of the prism. So we have our radius and our height. So we write our formula, base area times the height. Replace that with pi r squared times the height. Plug in the values we're given. And 8.3. Work down to solve. Volume is, I get pi times 25 times 8.3. Some of you might plug it into a calculator here. And what you get is 651 55 cubic centimeters. Very last two. Yay! Try them out and make sure you have all this written down. My notebook is much more neat than this stylist is allowing, and I'll show you that if you'd like. So, looking for volume, and the directions say to round to the nearest tenth. So, my volume is base area times the height when the base is a circle. So, I'm using pi r squared times the height. So I'm using the radius of 3, height of 1.8. 3 squared is 9, so it's 9 times pi times 1.8. So then working that out, I get 50, 868 10,000ths, rounding to the tenths. Volume is approximately 50 9/10 cubic inches. And here we go. Again, you work at your own pace. You pause when it goes too quickly. Volume is base area times the height. Repetitiveness will help you out in the long run. Base area is of a circle. My radius is 2.4. My height from base to base is 9. Imagine turning the nuts on its side. My radius of 2.4. Squaring that, multiplying the whole thing by the height of 9. Volume is pi times that square times 9. Multiplying that together and getting, I'm using 3.14 for pi. Rounding to the tenths. Volume is approximately 162 and 8/10 square cubic meters. That was a lot of stuff. You guys did a great job. I hope showing your work, getting in the habit of saying, hey, what area formula do I need? Plugging into that and working down and labeling. See you soon.